Section 1A, whole number place values. So we're going to start talking about different sets of numbers and how number systems work. So we're going to start with natural numbers. Natural numbers are the set of numbers that you use for counting. 1, 2, 3, 4, 5, 6, etc. So that's the set of natural numbers. 1, 2, 3, 4, 5, etc. Now, when we're dealing with sets, we're actually going to put the set of numbers inside what we call braces or curly brackets. They look kind of like square brackets, but they got the little curlies on them. So that's how we define a set, using those braces or curly brackets. And if we have something that continues on like this, 1, 2, 3, 4, 5, 6, right? It continues on forever. We're going to use a little dot, dot, dot. It's 3 dots. That's called an ellipsis. An ellipsis, it's the 3 dots that say something continues on forever. So our counting numbers, we can start counting at 1, 2, 3, 4, 5, and then we can keep counting for as long as we can. So that's our natural numbers, 1, 2, 3, 4, 5, 6, etc. Whole numbers are the natural numbers with the addition of 0. So whole numbers, let me do a better bracket than that, starts at 0 and then 1, 2, 3, etc., etc., right? The ellipsis. And we close that off. So those are our whole numbers. So the whole numbers are natural numbers and 0. A set is considered to be infinite if it goes on forever and it can't be counted. So like the set of natural numbers is infinite. It starts at 1, but it goes on forever. There's no stop to it. Same thing with the whole numbers. It's infinite. That term being infinite, right? Means it goes on forever. Will never stop, can't be counted. I'm just going to put it down as never ends. As opposed to something that is finite, which ends. It's not infinite. It can be counted. If I want to list all the natural numbers from 1 through 10, that's a finite list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whereas if I want to list all natural numbers, that's an infinite list. 1 through infinity. Keeps going on forever. So let's look at a large whole number. Something bigger than these things that we have up here, those single digits. Let's say we have 2, 1, 7, 3, 6, 4, 2, 9, 8, 2, 1, 5. Now that's a pretty large number, and boy, I don't even know how to say that one. At least not with a quick glance. So what we do when we deal with large numbers is we break them up into what we call periods. Periods are sets of 3 digits. And starting from the right-hand side, we do the count of 3 digits, and then we put a comma to separate the period. So we have 5, 1, 2, so 1, 2, 3 digits, comma, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3. If we had another digit over here, we put another comma. But now we've broken this up into periods, sets of 3 digits. Those periods have names. The first period is called the ones period. The next period is called the thousands. millions, billions, and if we win another period, trillions. And they keep going on with more and more names, which, to be honest, people really don't deal a lot with them beyond trillions. So if I were to add another digit here just to give myself something to work with, maybe I make that a 4 there, and so now I can say this one is trillions. And that's what most numbers we deal with fit into this. Yes, it can go beyond that, and there are names for all of the larger ones, but to be perfectly honest, most people don't know those names. Yeah, if you got up to the next one, I think that's quadrillions and then pentillions and stuff, but you're never probably going to have to deal with those. Although this you have to deal with because trillions, that's the national deficit, right? Billions, how much money they're spending on the stimulus packages for COVID-19. Millions, the number of people who have caught the COVID-19 virus. Thousands, the number of people in a certain area who, well, number of people in your hometown. Thousands. Ones, number of people in our class. So we have these periods that we deal with. Now within these periods, we actually break them up into 3 pieces. So if I bring down this 215, I'm just going to change to a different color. I say 215, then that can be broken down into 3 pieces. And each period breaks down into those same 3 pieces of ones, tens, hundreds. So you got ones, tens, hundreds. And they all break down into that. So if I was to look up at this big number up here, then I could look at this and go, oh, 215, that's the one, so I have 5 ones, 1 10, and 2 hundreds, or 215. If I look in the thousands, I have 298, that's the 2 hundreds, 9 tens, 8 ones, or 298. If I look in the millions, 364, 364 million. 217 billion. 4 trillion. So now I can break down this number and put it into words. I can name it. I have 4 trillion, 217 billion, 364 million, 298,215. So I can take this really big number and I can break it down into smaller pieces so I can read it. Now, I'm not going to write down a number this big in words because that's a lot of writing and my handwriting's not that great. So what I'm going to do is I'm going to take a little bit smaller number and I'm going to take it from standard form. Standard form is the word written as numbers, and I'm going to put it into, the number written as digits, and I'm going to turn it into words. So let's say I have 5,026. So I look at this first and I see I've got the period of ones and of thousands, and I can say I've got 5,000. And then in the ones, I've got 2, 6, so 26. So 5,026. Now be careful when you're taking a word from, a number from standard form and turning it into words. Don't throw an and in there. We have a tendency to say 5,026. And gets reserved for a very special thing that we'll talk about in a couple videos here. So don't put and in there. That's 5,026. Okay. Notice also when I'm dealing with numbers from 20 to, I should say from 21 to 99, that I tend to put a hyphen in between the tens place and the ones place. 26, so it's 20-6. 48, 40-8. And that ties those together. So that's one of the things we do. And notice we still break it down, and you can even put commas in if you want, and say 5,000, comma, 26. So we're able to take it from standard form, the numbers, and put it into words. Let's try another one. Okay, so that's a little bit larger number. So we look at our periods first. We have the ones, the thousands, the millions. And then within them, remember, we've got the hundreds, tens, ones, hundreds, tens, ones, hundreds, tens, ones. So if we're looking at this, we have 14 million. So I write So I write it in words. 14 million. And I can put a comma there. 619,000. $619,000, comma, 3. Ran out of space there. So I have 14,619,003. Remember, don't put an and in there. So that's going from standard form to words. But many times we don't have to write out the number in words. We just need to be able to read the number in words. So if I have 604,192,400, I just look at ones, thousands, millions. 604,192,400. So that's going from standard form, the numbers, into words. What if I go the opposite direction and I have it in words and I want to put it into standard form? $12,047. So now I'm looking to see, first of all, the periods, right? 47, that's in the ones period. 12,000, that's in the thousands period. So I got those two periods, so I know I have 12,000, and then we got the ones period, 47. Remember, there's 3 places in the ones period, right? There's the hundreds, the tens, the ones. So 47, that means there's nothing in the hundreds place. And then there's 4 and 7, so I have 12,047. Whenever you're converting from words to numbers or numbers to words, it's always good to convert back again just to check and make sure you've got it right. So 12,047, I wrote it down, 12,047. Now I read it back to myself, that's 12,047. 12,047, it matches. So that's a very good way to make sure that we actually got it correct. Let's try another one. 6 million 400 75. 6,475,000. Well, we look at that and we go, okay, 475, that's the ones period. I don't see thousand anywhere, so I have an empty thousands period, which if it's empty, that means we put zeros in there as space holders. And then we have 6 million, so we have a millions period. So we have 6 million, 6, comma, there is no thousands period, so 0, 0, 0, 0 thousands, right? And then 475, 475. And then I read it back and I go 6,475,000, 6,475,000, and it worked. So it's always good to look at it afterwards and convert it back and see how that worked. Well, now that we have the ability to go from standard form to words and back from words to standard form, let's look at recognizing the place values. So if I give you the following number, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I get very creative on the numbers that I use, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I ask, which number is in the thousands place? Thousands place. Now, don't confuse the periods with the places. When we say thousands place, we're really saying the 1,000s place. Right? In the thousands period, we have the 1,000s, the 10,000s, the 100,000s. Within the ones place, we have the ones, the tens, the hundreds. Within the millions period, we have the 1 millions, the 10 millions, the 100 millions. So don't confuse the periods with the places. So if we're looking for the number in the thousands place, that's the 1,000s place, that's this right here. So 6 is the number in the thousands place. What if I want the number in the 10 millions place? Well, this is the millions period. That's the ones, the tens. So the 2 is in the 10 millions place. What if I want the number in the hundreds place? Well, the number in the hundreds place, that's in the ones, tens, hundreds, that's 7. So that's identifying which number is in a certain place. The other way we can look at it is what place is a certain number in. So what is the place value of the number 5? Well, the number 5 is right here. This is the thousands period. That's 1,000, 10,000. So the 5 is in the 10,000s place. What's the place value of the number 9? That's in the ones place. The place value of the number 1. This is the millions period, so that's the 100 millions place. What about the number 3? The 3 millions place. Right? So once we know the place values, we can determine what number's in a certain place value, or we can determine what place value a certain number is in. So that's topic 1A, whole number place values.